clovers in my pocket. Count 'em like the four-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want.
Good evening and welcome everybody, this is Obi-Wan Pez for Simplex Pachinko. We are, well, I had planned on having this, updated so that I could spit all of the Spotify information over here. This has been Pretzel for the last few months, basically since I started streaming and had music. But Pretzel has been uncooperative lately, so we decided to be uncooperative back and not use them anymore. So they yes, thank you, Les. I went to a barber and actually got a haircut and a beard trim, and yeah, every single I gotta tell you, even if it doesn't, like, even if they don't take the beard completely off, it usually takes off about 10 years. Yep. So they yeah, they do a really good job, and they like use a straight razor and clean up all around here and stuff like that. And yeah, I don't mess with that stuff. I just have my regular razor that I get like under here and over here, and that's about it. If anybody has any questions about mathy type stuff, tonight's the night. I have here Math Horizons, published by Mathematical Association of America, November 2008. We can pop through some of the questions they have at the front. This was actually a colleague's of my a colleague's copy, and then she retired and like basically threw everything that was in her office at me and was just like, here, take all this. Okay. So if y'all have any questions, let me know. Otherwise, we'll attempt to answer some of the questions that are in here. Yeah, I pretty well embody the meme of the guy who looks like a gruff pirate when he has a beard. Yeah, that one. Make sure my name's not on here for some reason. Okay. That didn't do it. I had it locked, so.
An Apple original film, Blitz.
Please, Mum, don't set me away. It's only until all this is over.
Steve McQueen's Blitz is a triumph.
Your son did not arrive at his destination. You were meant to be looking after him. Where's my boy?
Critics rave. Saoirse Ronan is superb.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of November. Subscription required.
Calling all dunkers. What's a brew without a biscuit, eh? But this is no dunk to be left to chance. Dip your bicky and count. 1 Mississippi, 2 Mississippi, 3 Mississippi. Whichever online casino you play with, set your deposit limit so you don't overdunk. Take time to think. Sky Vegas. Play. It's why we're here. 18+ begambleaware.org.
The new all-electric e-Sprinter from Mercedes-Benz. Just like you, it means business. It means up to 200.
Oh, right, yes. Spotify also demands that we have ads. That might actually be a problem now that I'm thinking about it. I don't know. We'll let this one go and see if Twitch yells at me. And if they yell at me and try to do something, then I'll just delete this this VOD. So, see how it goes.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to saturated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance, not the life I want to live. I want to take it all, standing tall, fear I weighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it in
Alright, so the binomial expansions. Question here says why. Why is there the connection between the binomial expansions and Pascal's triangle? We've talked about this a number of times on stream, and my first knuckle on my middle finger keeps getting air in it. It just keeps having a pop. It's terrible. Hey. So we've talked about this a number of times, but the idea here is that Pascal's triangle has to do with choices. Or at least the particular application that Pascal ended up using it for was that it was all about choice. So what we're doing is we're saying, okay, we've got x plus y times x plus y. We're saying, how are we going to multiply these things together in terms of the expansion? Basically what we're doing is we're choosing one term from each of the bins and then saying how many different ways can we end up with these same things. And we're saying that all of the x's and then all of the y's are the same as each other, right, as themselves. So all of the x's are the same as all the other x's, all the y's are the same as all the other y's. There's no difference. It's just a matter of saying, like, okay, either we have one bin and x and a y are there, or the heads and tails are there, and then we're making a choice out of that bin, whether it be an x or a y that we're physically pulling from something, or a coin flip, right, either heads or tails. And then there is an equal probability that on the next time we do this exact same thing, we end up with the same stuff with equal probabilities. In the case of coin flips, that one's obvious. Everything's 50-50. No. That's the... Okay. Just, I don't know how much this is actually going to cover my rear, but that is the full copyright free playlist. By NCS. So that is, it's actually the same group that did the stuff for Pretzel, but there was a bit of a problem with that, again, just because they only had like 75 minutes worth of songs. It just kept repeating over and over and over again. So that was quite annoying. Especially when we kept getting to The Floor is Lava over and over again. Okay, so
Once it's in your mind, it's infectious. So fight for your life and reject it. You better give me space, I'm protective. My adrenaline spikes when I'm threatened. And if you stay in my way, I'm aggressive. Cause when there's no exit, I'll kill when I'm desperate.
So the number of choices for each arrangement are the coefficients. So with a choice of either selecting an X or a Y on each step, then we end up with, in this case up here with one, either there is one X or one Y, that's all you've got. Up top we have 0 X's and 0 Y's, it's just one. Right, and just as a reminder, this one is here because choosing nothing is also a choice, or not being able to choose something gives you the choice. The arrangement, the number of ways in which you can select X or Y is just one. Like there's nothing there. In the case of 2, now we have to choose an X from one of the bins, or we choose a Y from one of the bins. So the only 4 options here are we choose an X from the first bin and an X from the second bin, a Y from the first bin and a Y from the second bin, or the more interesting ones, we choose an X from the first and a Y from the second, or a Y from the first and X from the second. And in those cases, we end up with 2 different ways to get the exact same outcome at the end of it. So this is why we have 1x squared, right? You have to choose x on both of these. 1y squared, you have to choose y on both of these. And then 2xy, because again, one of them is choose y then x, and one is choose x then y. And similarly, when we start adding more and more and more choices, how many times are we going to pull something out? Then we end up with this particular binomial distribution of these numbers. And as I've said before, if you add a third choice, so x plus y plus z, then this is going to end up with a tetrahedral shape, and rather than a triangular shape like Pascal's here. And if we expand beyond that, we end up in n-dimensional, shouldn't say n. Right, we could do it as like x1 plus x2 plus ... plus xi to the n. This is going to be an ith dimensional. simplex. So anybody who doesn't know how the channel got its name, right? This is where it comes from. We have an ith dimensional simplex. In my case, I let it be n simplex. It actually causes the n to go down in the subscript instead of as the exponent, but it's all good. Most people are perfectly happy with it. It's fine. Right, and then again, the depth or height of this simplex is going to be, in this case, the n term. That's where that one goes. And then the distribution ends up being completely different for all of those. The good news is that the face of, or each of the faces of the ith dimensional simplex is going to be based on the distribution we get from Pascal's triangle, which is the I-1th dimensional simplex. So in this particular case, right, we can use this 2D image 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, etc. as each of the faces of a tetrahedron, and then from there we'll have to work in what the innermost values are. Now, I did figure this out many years ago when it was tasked to me by my dean, who was starting up the Journal for Research in Progress. And I figured out that you can actually call this, well, first of all, the one that we have up above, where we have just x plus y to the nth, right? This is going to end up getting us this binomial distribution.
Mississippi, 2 Mississippi, 3 Mississippi. Whichever online casino you play with, set your deposit limit so you don't get drunk. Take time to think.
All right, and with this being the binomial distribution,
we know, music interruptions aren't fun.
the individual exponent, no, not exponents, the individual coefficients that we get for this, n choose r is going to be equal to, okay, and in this case, n n is all these numbers here, and r is the number of terms that we're going in or out, whichever way you want to do it. It doesn't matter to me, because right, so what we can do is n choose r is the number of, in this case, in the way that I've drawn it, what is the number of x's that we want, given that we are on the 5th row, or the maximum number of x's that we could possibly pick is 5. So this is going to be okay. Oh wait. 5 choose 2 is going to be down on the 5th row. We're going to choose that we want 2 x's, and in doing so we end up with this coefficient of 10. This is all very well and good, and it's very helpful, but then this is one that we heard several times on the other channel. Uh-oh. We're just kind of... I'm having some interesting Twitch issues. I think everybody else is too. But it's kind of kicking on and off and saying that I just entered the chat room and things like that. Okay, so what I did for the binomial distribution was I said, this is the same as when I teach it to students who are trying to take, it's basically a math literacy class, so I taught it a few times before I left my college, but the idea is that we're going to take the number of items that we could choose, so 5 items in this case, right? And we're going to say, in how many different ways could you take those items and arrange them? Just trade them around on a desk. Now, if they are playing cards, there we go. Yep, I have at least 5, so that's good. Right, I take 5 playing cards, and I show them out like this. How many ways could we arrange these 5 playing cards? Well, here's 1 arrangement, 2 arrangements, 3 arrangements, 4 arrangements, 5 arrangements. Right, and then we could do the same thing with all the rest of the cards, mix them up, shuffle them around, and do all sorts of different orders. And in fact, when we get into it, right, there are 5 factorial different ways to arrange these, 120. Because we can say, okay, we're going to fix the first card, and then how many different ways can we arrange the other 4? Okay, well, that's the same as saying we're going to fix the we're going to fix, you know, the 10 of hearts is now going to be the first card. And then we're going to say how many different ways can we... That's not where I wanted to go with this. It's all cool. Okay, let's say we fix the 10 of hearts as our first card. Well, that leaves 4 other cards. So let's fix the 10 of spades as the second card. And then let's fix the 8 of hearts as the third card. So now, how many different arrangements do we have of those things? Well, we could take this and just change the order of these 2 cards, and that's it. So there's going to be 2 different ways that we can move around 2 cards. If we add back in the third, then on each of those 2, this 8 of hearts could have been first, or second, or third. So now, those are 3 different ways that we could have arranged these 2 different arrangements of cards, which means we're going to do 3 times 2 gets us 6. Alright, now do the same for the 10 of spades. Our 4th card could have been added first, second, third, or 4th position, and the other 3 could have been arranged in any particular order. So we take those 6 and then multiply by 4, and we end up getting 24. Puyuika, hey, how's it going? Good evening and welcome. My name is Obi-Wan Pez, and this is N Simplex Pachinko. And then similarly, if we just add 1 more card, you've got 4 factorial is 24, so then multiply by 5, because now we've got 1 first, second, third, 4th, or 5th position for that 10 of hearts. So we just keep doing this for however many objects we have. So here, this is just going to be n factorial. Oh, you've got to be kidding me. I did not plug in my headset. Cool. That was something I should have done last night. Completely forgot. So we say, okay, that's going to be n factorial. Then we say, what if we do actually want to care about, what if we want to not care about the particular order of the cards? So for instance, these 5 cards are shuffled and dealt out to you, and you have them in this particular order. Well, let's say I am a poker player, and I would prefer to have them in increasing order, like this. Yeah, it's pretty much the same thing, because they were in decreasing order before. But anyway, if we want them in increasing order, then I don't care what order they were shuffled and dealt to me. So the particular locations of all of these things, I don't care. So one of the ways to do that is to say we're going to divide by all of the times when those cards were in any particular arrangement. Right? We're going to say, I don't care in what order these 5 cards were. Right, so, sorry, if we're doing 5 choose 2, we're going to say, if we're doing 5 choose 2, then I'm choosing 2 of these cards and setting them aside. How many different ways could we choose those 2 cards? So in this particular case, this is going to be, again, we're choosing 2 cards. So 1, 2, and I don't care which one's first and which one's second, so that's dividing by 2. Right? And this is the 2 factorial of, let's rearrange these 2 cards. So 5 factorial divided by 2 factorial. Then the next question is the other 3 cards that we had. Well, I don't care about the order of those either. So the eliminating the order of the ones that we did pick is going to be our 2 factorial, and eliminating the order of the ones we did not pick is going to be 3 factorial. Again, the number of things that were remaining. So here, eliminate order of chosen, and here eliminate order of not chosen. So in this particular case, or in general, the stuff we picked was R, and the stuff we didn't pick was going to be N minus R. So what we do is we just say, okay, those are also going to be factorial, because again, we want to not worry about their particular orders. So in doing so, now we've got N factorial divided by R factorial times N minus R factorial. That's all well and good. But what happens if we have 3 things now? So now we have a trinomial distribution. So this is still going to be n, because we want to know what row we're on here. Where in the tetrahedron are we going to be? But now we have to specify 2 different directions. So how far through this dimension are we going, and also how far through this dimension are we going? How far across the row and how far through the tetrahedron do we need to go? So this ends up being like R1, R2 as our 2 directions. So in doing this, we still have n factorial because we just have that many chosen things, and the number of arrangements that we can make of all of them is going to be n factorial. And then we say, well, we don't want to know, or we don't care about the order of all of the things that are in R1, our first choices. And we also don't care about the choices, the order of the choices that were in R2. So we need both of those things in the denominator. And now we have here n minus R1 plus R2 as parenthetical, all factorial. Or we could make it n minus R1 minus R2, or we can make it n minus the sum of all previous r's, or, and this is the kicker, this is what got me really excited about this, I said, what if I just make this the product of all r's? I goes from 1 to n. That's not, no, I'm sorry, that's not n. Oi. It's I, because I chose very poorly. J. Goes from 1 to I. What the dimension is of the overall distribution. So again, the dimension of the distribution really is talked about in terms of how many things are we choosing from. $52 factorial is such a huge number that even universe's lifetime would not be enough to exhaust all. Yeah. Yeah, 52 factorial is a ridiculously large number. I mean, if you want to know how large are we talking, keep in mind, right? Like every whole 10 that you're multiplying by is adding another 0 onto it. And if we're doing something like, again, this is going to be 52 factorial. It's 52 times 51 times 50 times 49 times 48 times 47 times 46 times 45 times 44, etc. Dot 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 times 2 times 1. Right, so when we do this, keep in mind, like, all these whole numbers, if they, all of the even tens, if they have a 0 in the end, you're multiplying by another 0, it's adding another 0 to your number overall. And then also, you've got other numbers which can, like, 2 times 50 is going to get you 100. Okay, that's 2 zeros. Now we've got still 50 more numbers left to account for. Right, so there's just a lot of stuff here. It can end up being a huge number very, very quickly. So factorials are one of those things that are some of the fastest growing function values that can exist. If anybody does have any questions, let me know. Otherwise, I'll keep ranting. So that's the connection between Pascal's triangle and the binomial distribution. Again, we can get trinomial, and then we get multinomial distributions, which end up, again, this is going to be here. This is NC bracket R1 comma dot 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 comma R sub J. We want that one. No, I. We still want I, because we R sub I. So again, this last term here, the n minus the sum of all previous terms, or sum of all previous r's, is really just if you're going to insist on not using, in this case, for instance, R3. Like, you know how big it is. So, to me, it doesn't matter whether you just call it R3, or you say it's n minus all the rest of them, you know, some of the rest of them.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of November. Subscription required.
Calling all dunkers. What's a brew with
Number
a
4
biscuit?
says classic surprises.
But this is no dunk to be left to chance. Dip your bicky and count. 1 Mississippi, 2 Mississippi, 3 Mississippi. Whichever online casino you play with, set your deposit limit so you
Right,
don't
the
do it.
interesting part was that we have,
Sky Vegas, play.
if we take
It's
the
what
powers
happens
of
when
11,
most
for
people
example,
don't.
right? 11 to the 0.
Music interruptions aren't fun. But real quick, heard of Labara Mobile? Maybe? A Which-recommended mobile network with a 4.8 star rating on Trustpilot. Oh, and also named the most popular mobile network at the U-Switch Telecoms Awards 2024. Well, we just had to tell you that now you can join Labara
Okay,
from just £5 a
so
month. No
here
cost,
we've
no
got
below poverty.
0, 1,
Join
2,
Labara from just £5 a
3,
month.
4,
Labara, the smarter mobile network.
11 to the 0, 11 to the 1st, 11 to the 2nd, 11 to the 3rd, and 11 to the 4th. Right, what is the digital representation of these things? 11 to the 0 is just 1. 11 to the 1st is 11. 1, 1. 11 squared is 121. 11 cubed is 1,331. And 11 to the 4th is 14,641. Anybody see anything that might be sticking out like a sore thumb? Hi, Spy Pascal. Absolutely. How's it going, Femvox? Alright, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And then here, right, it asks, the editors here ask, does the pattern continue? And it's cool and all, but there's a bit of a problem. Were you over on Tofu's? Anybody who doesn't know Tiny Toxic Tofu, awesome streamer. She is a physicist and also Irish, so I tend to spend a bit of time in there whenever I'm feeling like hearing about some cool sciencey type stuff. I used to be very much interested in learning more and more physics. I probably need to still learn some more physics, but nonetheless, that's what this was for, right? Oh no. Too many books in the way. Yep. This was... I have all 3 of the books. The Feynman lectures on physics. And at some point, I think we're going to go over a bunch of that stuff on stream, just cause it would be helpful for me to go over it as well. Right, so the issue here is that our numbering system is inadequate. Due to the fact that there are now 10s in the way in all of these individual places, that does mean that they're going to tick up 1 on the next number up. So in this case, we get this 10 ticks up this 5 to become a 6. This 10 ticks up the 0 to become 1. And then we get 0, 5, 1 after that. So, hardly fair, but at the same time, like, you know, 161,051 is going to be our solution to that one. Whereas this, all rest of the time, through n equals 4, right, 11 to the nth power is going to get you, like, the same as the Pascal triangle. And this is actually a faster way to do powers of 11. So if you want to figure out what is the, you know, 10th power of 11, then you probably, all you'd have to do is go down the Pascal triangle to where we end up on the 10th row. So in this case, 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1, 1, 8, 28, 56, 70, 56, 28, 8, 1, check me, 1, 9, 36, 84, 126, 126, 84, 36, 9, 1, and then 1, 10, 45, 110, 120, 210, 256, 210, 120, 45, 10, 1. Right? So then it would just be a matter of adding these up, and it'll be nice and easy, right? So this is going to be 1, 0. Next number up is going to be a 6. Next one's going to be a 4. Next one's going to be a 2. Then 8. Then 7. Probably doing this wrong. It's all good. Should be 3. 2, 2, 5 should be a 9. Gosh, I hope this is right. I haven't had any extra added, additions here, so that's interesting. 1, 4, 0 is a 5. And then 0, 1, 1 should be a 2. So, allegedly, let's double check that one. Um, 11 raised to the 10th power. Alright, so this is 25 billion 424,601. It's very interesting that it's that number and only that number. Alright, so how did I do this? Let's see. That is taken care of. That was, I probably double counted. Right? Ones. Ones and the tens before it, so there aren't any. Then tens and the ones after. Yeah, tens and the ones after it get a 6. Then tens, the ones after it is 4. And then tens and the ones after it is 2. Got that. Then hundreds. And the next tens. And the next ones. Oh, did I mess up? Ah, that was it. It's not 256. It's 252. There we go. Well, at least that's an easy fix. Right. Not 256, 252. Okay. So yeah, I jumped the gun on this one. I was like, yeah, 256, but no, it's a 6 and a 6. It can't end in a 6. Okay, so 25,937,424,601 is 11 to the 10th power. And again, you could do that by looking at the expansion of the Pascal triangle, binomial expansions, all thanks to, yep, forgot again. Al-Jayyani. There we go. So the original distribution of the binomials like this, and I'm assuming he also probably did some with the trinomials as well, was mostly due to al-Jayyani in and around the same time, roughly speaking, as al-Khwarizmi. It's like 10 to 1200s ish. Al-Jayyani had a binomial expansion of a plus b to the n up to n equals 12, allegedly. Okay. Okay. So looking at this, then that means that yeah, okay. So then it says to be left as an exercise to the reader, right? What about patterns in 101 to the n or 1001 to the n? So if you use the same stuff as what you had in the Pascal stuff in the previous section, then we start looking into just some interesting patterns. In this case, we're going to get hundreds all raised to large powers, and that's going to get rid of some of the issues that we had back here with needing to carry numbers. So we're going to be leaving a certain number of zeros that are just blank, and then eventually they can be filled in. Depending on how many zeros we're going to, or how many decimal places we're going to take up.
An Apple original film, Blitz.
Please, Mum, don't send me away. It's only until all this is over.
Steve McQueen's Blitz is a triumph.
Your son did not arrive at his destination. You were meant to be looking after him. Where's my boy?
Its raid, Saoirse Ronan is superb.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I've found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of
It's not necessarily going to be 2 to the n specifically, but
walking speed tracker, a confusing fringe show's data analyst, or maybe an unpredictable footy schedule manager? It doesn't matter, because whatever you do, however complex or intricate, Monday.com can help you organize, orchestrate, and make it more efficient. With automation that saves you time and integrations for all the tools you use, Monday.com is the one centralized platform for whatever you run. Go to Monday.com to learn more.
okay. Now here's a maybe somewhat bold claim. I don't know. I can reason my way through half of them instantaneously. No worries.
In any order without hearing outbreaks with Spotify Premium.
All alternating sums of any row beyond the first is going to be 0. So we could check this just over on the Pascal triangle and say, okay, based on this here, beyond the first one, 1 plus 1 minus 1. Okay, obviously. Plus 1 minus 2 plus 1. Okay, yes, that's also a 0. Plus 1 minus 3 plus 3 minus 1, also 0. Plus 1 minus 4 plus 6 minus 4 plus 1. In this case, right, our 1 and 6 and 1 are positive. They add up to 8. And then our 2 4s add together to get us negative 8. So 8 minus 8 gets us 0. I'm going to say it's pretty obvious on all of those. Right, so obvious on odd rows. Right, every other term gets to be a negative, and then we're going to end up further along past the midpoint. It's just a mirror reflection of of the same row. So 1, 5, 10, 10, 5, 1. In that case, each of them has been positive on one side and also negative on the other. Like the parity of R, the location of each of those numbers, is going to be the opposite. Right, for n equals 1. Right. Now I'm wondering if induction would be easy. Probably not, but you know. Alright, fair enough. Ads just went off. So we'll hang out, we'll think. Alright, we're also gonna do some screaming tonight, cause we got some new sticks. This is probably the last purchase of sticks. These are just plain rattan, but the idea is that they're going to do a lot less damage to the other guy's sticks, because my plastic ones have been doing bad things to the other guy's sticks. So the rattan, when it smacks against hard objects enough, begins delaminating a bit, and I mean it's bamboo basically, so it starts splitting and like individual shreds start popping out away from it. So so we're gonna start with our standard, let's see, so here you're gonna come out and then back, out, back, out, back, out, back. And then, let's see, number 2 is just doing it twice. That's kind of boring. Number 3 is an overhead, and then back like that. Oops. Overhead. Wait, hang on. That's right. So, It's an overhead strike, and then we're bringing it back across our body pretty quickly, and then going out for another strike like that. So, I keep doing it wrong, that's the problem. Nope. Don't move the other one. Right, and then I don't remember like all of the other. It's been so long. But here, try to keep this in around the body. My wife was hearing me do this, and she's like, "You just like the whooshy sound, don't you?" I'm like, "Well, I mean, that's nice, but it's not the primary reason." Nope. And then that was that. And then we do the sticks to heaven stuff. So standard was coming V shape, strike back, strike low, swap back, strike up, strike low, swap back. It's weird, I've said this before, but it's a 5 count. So you're doing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And it's just very awkward to have a 5 count in the middle of this stuff. And then, let's see. I also did from here down, up, like that. Yeah, these move way faster. Alright, we also have the side strikes like that. And then we were doing something else. Oh, right. We just learned this week how to keep both of them moving at the same time. I'm not particularly good at it, and I'm worried it's going to like really make a lot of noise. But hey, here we go. Let's see, so it's coming from here. Is it this? I think it's that. So basically you're just taking them across from each other like this, and then... No, this is wrong. Okay, hang on. So you bring it down, cross, and then once you cross, bring them both back up again. So, I'm doing it wrong again. Hang on. Come up under. Come up under, swap. There we go. That's it. So they're coming from here. We kick them both up under, and then we're doing 2. Yeah, that's it. We're doing 2 upper strikes. So it gets really awkward really quickly, and it's also 2 downward strikes later. But he was trying to get us used to this. So like they come back under, you cross, and then you twist your wrist the other way, and then come back up again. Ideally, these strikes are always going to be at 45 degrees, and that's part of the problem. So if we did this way, yeah, downward's a little bit easier for me, I think. So The idea is that like the sticks to heaven stuff is getting one stick moving at a time, almost exclusively, except that one place where they swap. And then we're doing this other movement where both these sticks are moving at the same time, and they're kind of symmetric to each other. And so if you're doing that, then a lot of times people won't be able to move in on you, because they're like, whoa, okay, you've got two giant sword-type things that are coming at me. I don't like that. So they'll try to find another way around, and that's when you switch to something like this. And then, he said when they're, you know, if somebody knows that trick, then one of the other things you can do is, instead of moving one stick at a time, or moving both sticks pretty much exactly the same, you do a follow technique. So our right side comes first and goes across, then the left one follows it. So they essentially are like about an eighth out of phase with each other. And then you return to here. And that would have just caused me to... These are never going to be blades. Right? So you start doing your like sticks to heaven, and then you do a follow, and then you return to here, and maybe you do a... Oop, nope, not that way. Do one of these. I'm doing it wrong. Which way is it? Do one of these, followed by more. Ah. So there's going to be like a lot of different motions that end up producing different combinations, and the idea, I mean, as with everything really, is that you're going to you know, learn the basic techniques and then start making it your own. So do something cool with it, something that's unexpected, because if you just follow the textbook, then like somebody who knows the textbook is gonna just be like, stab. Like, oh, you're doing this followed by that followed by that. It's a pattern. Alright. I'll just look for my opening, because that's all it's gonna be. It's just a matter of looking for an opening. But if you're slightly chaotic about the way you're doing it, and it's not patterned after anything in particular, or as our instructor said, somebody who was like, oh, I just made a mistake, and he's like, well, nobody's gonna be able to guess what you're doing then. It looked good. Right, so
It's only until all this is over.
Steve McQueen's blitz is a triumph.
Your son did not arrive at his destination. You were meant to be looking after
So like n choose r is going to be equal to n choose parentheses n minus r.
A masterpiece. Blitz.
Is that true?
TV Plus, 22nd of November. Subscription required.
Canva's magic right can improve any dull piece of work.
For
Canva's magic right turns
for all
into spellbinding
n
Canva's magic
odd
right
number,
sprinkles
2k plus 1, k is any integer.
Canva's magic right turns dull drafts
Positive,
into
but
salient soliloquies. Dull words designed convincing, eloquent, compelling, poetic with Canva AI tools. Canva, designed against dull.
okay, so if we do 5 choose Right, 5, choose 1. It's going to be the same as 5, choose 4? No, that's not correct. R plus 1? Okay, so extreme cases, right? 5, choose 0 is going to be 5, choose 5. Which is correct. And then 5, choose 1 is going to be equal to 5, choose 4. Yeah. And minus R. Okay. Yeah. This is fine. I was just not remembering something. It's fine. So as long as n is an odd number, n choose R is going to be equivalent to n choose n minus R. And R and n minus R have opposite parity. If R is even, then n minus R is odd. And if R is odd, then n minus R is even. Right? Corollary. Okay, does that work for all rows then? So R and n minus R must have opposite parity, therefore they will have opposite signs, because what we're doing is we're saying that this is going to be the sum as J R. As R goes from 0 to n. Then this is going to be -1 raised to the R. Yes. -1 raised to the R times n choose R. So this is going to be right, and choose 0 minus a. Well, thank you very much for the follow. Arg. It's Jeff. How's it going? Oh, you're already following me. Or no? Yeah, that's all good. Thanks for the bits too. I've got I'm having problems with some Linux stuff, so yeah, okay. Thank you. I'm having some problems with some Linux stuff, so I gotta get, what is it, DaVinci to work on here, so that I can actually make more, like, bit alerts, because those look like a lot of fun. I also need to make, like, actual videos and put them on YouTube, but, you know, it's fine. For now, it's just gonna be a lot of streams. Alright, so here we had n choose 0 minus n choose 1 plus n choose 2 minus ... And then this will continue on until we get down to the other end, which is going to be like plus n choose DaVinci resolve. Leave overlays to third party. Yeah. Yeah, DaVinci Resolve is a Linux version of the Adobe one. Premiere? Yeah, Premiere. And like, I liked Premiere enough, but yeah, video editing. I liked Premiere enough that like when it was paid for by my work, it was pretty nice. But now it's not paid for by my work because I'm not working there anymore, so. Okay, so the last one is going to be minus n choose n minus n, right? Because it's going to be, yeah, R is going to be n. Yeah, so all of my old
Here we go.
So the alternating sum isn't just 1 minus 1 because we have to prove that the coefficients end up, so it, like, x and y are still going to be x and y. We have to prove, sorry, no, it doesn't matter. We have to prove that for any row, right? For any row we want to do. So if I want to go down to, you know, row 9 here, right? Prove that row 9 is going to end up getting us 0 when we do that. So it's after you raise it to that power. Okay. Nah, I get what you're saying now. Alright. Yeah, I guess that's kind of the generalized version. Yeah, it has to come from that. True, yeah. I guess. Yeah, I mean, I would consider that like working an alternate method and maybe even slightly working backwards. Not that it's wrong or anything, I don't know. I feel like, for whatever reason, I feel like it's not quite answering it in the way that I want to answer it, but it's not like it matters. This would be a plus n choose n minus parentheses n minus 1. It's terrible. just do all that. Move that back. Just make it easier. That one's gonna be a minus. Alright, so this is NC0. This is plus NC1. This is minus NC2. Dot dot dot. This is going to be N choose 2, but positive. This is going to be a negative N choose 1. And then we get a positive N choose 0. Alright, and since it is an odd row, right, there is no explicit middle, so we're going to end up with just symmetric on both sides. Replace the coefficient with the sum of the two above it. Yeah, and that's also true. I feel like that would also work for an induction. So if you wanted to do mathematical induction, you could also do it that way. So if n is even, then how is that going to work? We already know, right? N choose r is going to be equal to n choose parentheses and minus r. Right, we already know that this is true. Then n and n minus r have the same parity.
An Apple original film, Blitz.
Please, Mum, don't set me away. It's only until all this is over.
Steve McQueen's Blitz is a triumph.
So this one might actually require you to use the one above it.
You were meant to be looking
The sum of the two above, which will end up helping it cancel.
Saoirse Ronan is superb.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of November. Subscription required.
The new all-electric e-Sprinter from Mercedes-Benz. Just like you, it means business. It means up to 272 miles of range for all those pickups and drop-offs. It means charging up in the time it takes to stop for a coffee. And it means unparalleled after-sales care.
NCR is going to be equal to R goes from 0 to N.
Talk to your local dealer today. WLTP indicated values based on a fully charged 113 kilowatt-hour battery. Driving figures may depend on weather, load and driving style, subject to availability.
We know, music interruptions aren't fun.
Okay,
But real
well, we
quick,
still need the alternate.
Heard of Labara Mobile? Maybe? A Which-recommended mobile network with a 4.8 star rating on Trustpilot. Oh, and also named the most popular mobile network at the U-Switch Telecoms Awards 2024. Well, we just had to tell you that now you can join Labara from just £5 a month. Low cost, without low quality. Join Labara from just £5 a month. Labara, the smarter mobile
Right,
network.
so we still get NC0 minus NC1 plus.
We're running out of options. I didn't know then, but we took every precaution. Now you're holding back, but I can hear the pain underneath your breath.
Okay, so you're going to have the same parity because if n is even, if r is even, right? Because n is even in this case. R is even, n minus r is also even. If r is odd, n minus r is also odd. Right, because even minus odd is going to get us an odd. Even minus even is also going to get us an even. If anybody wants to see that proven, we can also do that. Dot minus plus and C and minus -2 minus and choose n minus parentheses n minus 1 plus and choose n minus n. Okay, plus n choose 0 minus n choose 1 plus n choose 2 minus dot 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 plus n choose 2 plus n choose 1 plus n choose 0. Okay, so this is now twice the sum of our n choose r's, where r is going to go from 0 to half n minus 1. Because half n is going to be a single number. Right? It's just going to be by itself in the middle. It will be the middle. Alright, n factorial over n over 2 factorial n over 2 factorial also makes this rather interesting. n choose 0 is going to be the same as n minus 1 choose 0. They're both 1, right? Choose nothing, you still get 1 back. Then here we've got minus n choose 1 is going to be a combination of n minus 1 choose 0 plus n minus 1 choose 1 plus n choose 2 is going to be a combination of parentheses n minus 1 choose 1 plus n minus 1 choose 2 minus dot dot dot. Right, so then plus n choose n minus 2. Terrible. Is going to be n choose n minus 1. N minus 1 choose n minus parentheses n minus 3 plus n minus 1 choose n minus 2. Right, so I've got all these so far have been the sum of one lower than the thing we're trying to split up, and then its current value as well. So up here, to get n choose 1, we said it's both going to be n minus 1 choose 0 and n minus 1 choose 1. And then when we go over to the end, this is going to be the same stuff based on the n's values that we get here. Okay. So minus parentheses n minus 1 choose n minus 2 not that one, plus n minus 1 choose n minus 1 plus, yes, plus n minus 1 choose. Hey, finished it. Doing all right. Doing some work on Pascal's triangle here, so trying to clean up. It looks like it's cleaning up. Trying to clean up a few things so that it looks. That's kind of a lie. We're trying to see how it works. Specifically, like right now, why is it that the sum of all rows within Pascal's triangle are going to get us a power of 2? And also, why is it that an alternate sum of all of its digits going across is going to get us 0 no matter where we are? So we've already proven that it does alternating sums equals 0 on odd numbered rows. Now we're trying to do even. We've taken the previous row and said that every term is the sum of the two numbers previous to it. So we're almost done with that. Basic algebraic concepts aren't too hard. I don't even think I had the hard stuff yet. Yeah, probably not. Let me know if you have anything that you don't quite understand or something like that, and I can try to explain it a different way. Okay. And then I was gonna have the same parity. Oh, that's the end. Okay, no, this is the end. We're done. It's fine. Okay, so I think everybody should be able to see here that we have an n-1 choose 0 and a negative n-1 choose 0. So those are both gone. Then we have a negative n-1 choose 1, and we have a positive n-1 choose 1. This is a telescoping series. That all of the stuff that's in the middle ends up with a positive and a negative version, and when you put them together, they go away. Which means that there's only one thing that's left in all of this, and it's way at the end, which is... okay, hang on. Yeah, there we go. Yes. This is also n-1 choose 0. This negative comes in. It's going to eliminate this term with that term being positive. I feel like something else is wrong. You know what?
An Apple original film, Blitz.
Please, Mum, don't set me away. It's only until all this is over.
I think these should all be n-1s.
Blitz is a triumph.
And then it would end here.
His destination. You were meant to be looking after him. Where's my boy?
Critics rave. Saoirse Ronan is superb.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of November. Subscription required.
Are you a professional tourist walking speed tracker? A confusing fringe show's data analyst? Or maybe an unpredictable footy schedule manager? It doesn't matter, because whatever you do, however complex or intricate, Monday.com can help you organize, orchestrate, and make it more efficient. With automation that saves you time and integrations for all the tools you use.
Yep.
Monday.com is the
Right.
one centralized platform for whatever you run.
So this ends up being 0. And then these pairs here end up being 0. And these pairs here end up being 0, etc., etc.
Canva's magic right sprinkles enchanting inscriptions into dull documents. Canva's magic right turns dull drafts into salient soliloquies. Dull words
These are also 0.
convincing, eloquent, compelling,
This one and
poetic
that
with
one.
Canva AI tools. Canva, designed against dull.
And then lastly, these two. Yeah, I had an extra term there. That's what the issue was. Very silly. Right. So, yeah, Puiwika, thank you very much for the suggestion there, because you're totally right. If you go to the previous row, you can also get rid of a bunch of stuff. Okay. Alright. I'm going to run downstairs, grab a drink, and refill my water. I think I'm good. Otherwise. And we'll just run ads early so that we won't be surprised next time. Right. So thank you everybody for sticking around. I'll be right back. If you do have any questions on math, please feel free to drop them into the chat. And if anybody comes around that is like, yay, chair raid, or whatever, then please welcome them on in and let them know that they can drop any questions they have in the chat. I'll be right back. Thank you very much. Righto. Thank you everybody for sticking around. Yep. Coming up pretty soon. Did it not? It looks like it didn't even go onto ads. Cool. Or did it? Yeah, it did. Okay, cool. It worked. Never mind. I was grumbling there for a second. Sorry. Tonight we've gone back to the Botanicalist Gin and Tonic IPA. Hashtag not sponsored. I remembered I found it interesting when I was confronted with it. So, Botanicalist IPA, Gin and Tonic IPA. It's got quite a head on it right now, which could be said about a lot of people in chat. Hey. I swear we've heard this in the last, like, hour. Oh, it's a remix. Okay, it's probably not the same. Shuffle. Drinking lots of water nonstop. Yeah, as long as it's, like, you know, healthy. Make sure you're not drinking too much water. There was that one lady who dropped dead after she got water poisoning. She was playing a game that a local radio station put on called Hold Your Wii for a Wii. Back when the Nintendo Wii came out originally. It's not funny, but like it's just a ridiculous concept. Coffee is also water. It probably doesn't have that many electrolytes either. Good times. Okay, so next question. Why is the sum of entries in any row of Pascal's triangle a power of 2? Well, yeah, okay. Putting water and antidiuretics together doesn't actually make it better. Or no, diuretic. There we go. Putting water and diuretics together does not make it better. It just increases the speed at which all of that stuff cycles. Represents total number of subsets, sizes 0, 1, 2, 3, etc. Yeah, okay. Why does that work? We're gonna be mean, Jeff. Can't use more advanced math to explain less advanced math. That's what N choose K means? Yeah, I mean... True. Alright, so we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Alright, we'll stop there. Why is it, right, that the sum of each of these things is a power of 2? 2 to the 0. This is 2, which is 2 to the first. This is 4, which is 2 squared. Alrighty. Well, good luck, edits. Do you go by anything in particular? I keep going back and forth on it. Very non-committal of me. 16. Which is, in fact... Oops. to the fourth. Right, 10, 20, 32, yeah. Ah, breakdown working at 25-minute intervals. Yep, okay, cool. Each interval is known as a pomodoro, the Italian word for tomato. Nice. I agree that generally speaking, that kind of thing does work. And I do apologize that my Pomodoro technique is potentially 3 hours in length. If it's math that I'm doing, it's absolutely gonna keep me occupied for as long as it takes, honestly. That's because it's my subject, you know. Okay, so it is actually the powers of 2 and those powers of 2. So it is actually 2 to the n. Another question would be, if we do have the trinomial expansion, what does that actually get us? So like that's 1, this would be 1, 1, 1, this would be 1, 2, 1, 2, 1, 2, this would be 1, 3, 3, 1, 3, 3, 1, 3, 3, with 6 on the inside. Alright, 1, 4, 6, 4, 1, 4, 6, 1, 4, 6. This is going to be 12, 12, and 12. Nope. Wrong locations, but same idea. It's 12 between the 6s. This is 1, this is 3. This is 2, 4, 6, 9. 6, 6, 6, and 6. It's going to be 24, 27. Okay, yep, it is powers of 3. Awesome. So that was lowercase I. So yeah, it's I to the n. Oi. And this should be 81 then, so 12, 12, 12 is 36. 46, 56, 66, and 12 is 78.
You were meant to be looking after him. Where's my boy?
Oh dear.
Is superb.
I just want to go home.
A monumental achievement in British cinema.
I'll be back when I've found my boy.
A masterpiece. Blitz. Streaming on Apple TV Plus, 22nd of November. Subscription required.
It's possible I messed it up somehow.
Your UK visa digital. If you have a BRP card that expires on the 31st of December 2024, or a stamp or vignette sticker in your passport, you should change to an e-visa now. This means it will never be lost and can be accessed online at any time to prove your right to
35-minute
work or study in the UK. It's free,
followed by
and your
15-minute
immigration
productive
status won't
break.
be affected. Find out more now at gov.uk/e-visa.
Right, it's 36,
Music
18,
is personal. Have the power to set
24,
the tone from start to stop with Spotify Premium.
and
Listen
3.
to all your favorite playlists and albums
Right?
in any order.
10,
and download
11,
any track to play offline.
21,
All with no ad breaks. Just
5,
uninterrupted
6, 7, 8.
music
Yep,
listening.
cool.
Tap the banner to learn more.
Right, so it's 3 to the 4th. 3 to the 3rd. 3 squared. Okay, that... I hit the paper, which is raised off of my tablet, and it wrote on the screen. It's not supposed to be able to read it when it's paper. It's so weird. Let's read the tip. As long as the tip is depressed while it's in the vicinity of the tablet, doesn't have to actually be touching the tablet itself. Messed up, man. Okay, so one more time, right? Why is it that each of these rows is going to be a power of the number of choices that we're making? You sum them all up. Right, because Jeff's completely right. This does have to do with like the number of subsets that you can create for each of the numbers that are out there. The number of different paths that we can take, because it's branching, right? So if we go at it from the perspective of what we're looking at here, right? So we're starting from one point and we're making a choice. We have one of two possible ways to get from row 0 to row 1. To get from row 1 to row 2, we have two choices from the left path and two choices from the right path. To get to from row 2 to row 3, we have each of those values again is going to end up getting doubled to that many paths. Oh. But these count double. Oh. Like this will go that way. Into 3, 4, 5, 6, 7, 8. Yep.
fall back. But you'll be there, ready to rescue me if I go out of track.
My watch band has been slowly breaking over a long period of time. I think it's finally had it.
What's on the other side of inhibition? Ooh, I do you do 'cause I'm feeling so cool.
Sitting at the same old workplace. What's the point of this chase? To just bite our old tail. Wishing that something would change, that we could turn back the page and live like our favorite fairy tales. So a love so free in a world of our fantasies, flying on dragons through sky-high cities. These are childhood dreams, it's how we used to be. When we were kings and queens in our childhood dreams. Oh, 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 our childhood dreams. Feeling, I feel so lightweight when I think back to those days, but then we went our own ways. I'm thinking about what needs to change, that we can turn back the page and live like our favorite fairy tales. So a love so free in a world of our fantasies.
If anybody does have any questions about mathematics, please let me know, and we'll work on your particular problem instead of just random stuff like mine. Geography question? I mean, you can go for it. I can't guarantee that I'll be able to do anything.
These are childhood dreams. It's how it used to be when we were kings and queens in our childhood dreams.
Find the shortest path from Brisbane to Cardiff that touches only water. Dude. So you want to find as many great circles as possible, essentially. Does the Panama Canal count? So you so yes, right? You can't just say, I want a great circle that goes from Brisbane to Cardiff. However, you can decide to choose to go from Brisbane, take a great circle from Brisbane, go to the Panama Canal. Right? And then make sure it doesn't hit any random islands in the way. Or like the little bit of Mexico that pops down. If it does, you just say, okay, back it up to that point. And then go great circle from there to the canal. Then you have to go through the canal. And then once it's through the Panama Canal, you do the same thing on the other side. You say, give me a great circle from the Panama Canal up to Cardiff. And then if that doesn't work, to the nearest piece of land, you know, to the nearest problematic piece of land that's going to allow me to just kind of skirt around it. It would be that way, I guess. Okay. You still do the same thing. You just say, okay, give me a great circle that goes from Brisbane to Cardiff. Then you say, okay, I can't do that, so let's find where it's going to hit land, and then like just slightly modify it so that you're saying, okay, this is going to be the first, second, third, fourth point that we have to navigate through in order to get it to go all the way around without you know, running into land. What can we do for this? Oh, that's interesting. Okay. I'm trying to look up the watch band to see what we got. And this one is woven nylon rather than, I don't know, rather than silicone, which is fine. I get the feeling it won't break. That's nice. Sweat, swim, and worry free. Nice. Magnetic. Yeah, but that's GTR and mine's at GTS. Crap. No, just go back. Sorry. Great circle map, roots, BNECWL. Right, so I would take Brisbane to Irkutsk, like go through the Bering Strait, and then go up around the top. Now the problem is that that is all ice, so there is a good chance that you're not getting through that no matter what. But if you're not too fussed about it, right? If you're like, no, it's fine. We just have to, you know, we can go through ice. It doesn't count for whatever reason. Then yeah, I would say go through the North Pole. So you want to go Brisbane to the Bering Strait to Cardiff, because that looks almost like a straight shot from the Bering Strait to Scotland anyway.
Listen to Top Supply 100 greatest Christmas songs ever.
So you're going to want to kind of like hit individual points that are going to be approximate. You know, it's going to be pretty close to it's going to be pretty close to a great circle. You're going to have like 4 or 5 great circles, but each with diminishing distances. You know what? A 3-pack might be good. Not leopard print. I know. I know. Alright, let's actually go back over here so you can given a pixel map of white and black pixels representing a globe, find the shortest path between any 2 points using only black. Okay. Yeah, so I think what you'd be doing is you'd want to start, so like I said, you'd want to start with a pure great circle. Let it cross whatever it's going to cross. Right, let it cross whatever it's going to cross. And then you say, okay, because it's crossing over some white pixels, you say, okay, this is not good enough, clearly. So we're going to find the... We're going to find, like, 2 great circles that would approximate it the best and have the largest amount of black. Have the largest amount of, no, that's not the largest amount. Have the largest percentage of black pixels only. So you probably want to try one man. Right? How do you do it? Yeah, choose a breakpoint. Break the one great circle into two. Obviously, if you just break it in the middle where it just is, then if it would not change the actual percentage of black pixels. And then you just say, okay, it has to move somewhere. So I mean, you might be better off making it like simplifying it and saying like, we just want to, man, I don't know. I guess maybe try it once every like 10 degrees or something like that. So like run it around the whole planet and then try to find the one with the greatest percentage of black pixels only. And you're only running it once every 10 degrees. Like from your original position, do 10-degree increments. And then whatever gets you the greatest one, start from there again. And then you should only have to do stuff that's like between there and maybe like the next 2 segments over. Question mark. And then shrink it down to like, 2 degrees within this small segment. So every 2 degrees, then you have like, you break it in multiple points. I don't know. It's yeah. Yeah, keep adding intermediate points, and then you want to find the largest individual segment of, so like, you had your, hang on, let's get this over here. Right, so if we go like this, right, so if we go like this, what you want, right, what you want from this eventually is to take the largest unbroken segment. It's terrible. Oi. That's almost better. Right, take the largest unbroken segment that you can do. And then from here, do the largest unbroken segment you can do again. So originally, yes, right? Right, because you're also checking which has the largest percentage of black pixels only. So you want to like vary the location of this thing, but you're not going to just randomly place it all over the place, right? I mean, you could do that, but you'd want to say, if I place this man, I don't know how to parse it is the problem, because I've never done a problem like this, really. longest black pixels are between Papua and Vietnam. So like where you have it right now, that's China. Yeah, don't let anybody Vietnamese hear you say that. Alright, Vietnam's over there. Currently. Yeah, okay. So, like, any amount of changing that point is going to make this better for the most part. Right? So, if we shift this... if you shift it this way, it will not exclusively get better. It could potentially get worse. But you want to take, like, everything between here and here. Right? Set these as your boundary. Be like, okay, I know for a fact. But you can't do that, right? The computer has to do it. Yeah. So, like, you could be moving over a few degrees at a time, right? Like, you could be moving over a few degrees at a time, and then once this is greater than some percentage change, you could be like, nah, never mind. We're not going to go that way. Because you also want the shortest path. So, like, maybe it's also... You could create, like, a fitness score. Yeah, eyeballing it is definitely easy. The problem is trying to generalize it and letting the computer figure it all out by itself. It's always the problem. The computer is a dumbass. Cumulative cost map. Okay. Or a directed graph. Okay, so how would that work? Right. That's right. We order stuff on Amazon through the other credit card. Okay, I don't like that. Amazon Prime has an AI called Rufus. Start with points touching Brisbane and find the cost to those. Okay. So, and again, it could be that you're deciding long distance, right? So you don't have to necessarily choose points that are like within a couple degrees of Brisbane and choose, you know. Ooh, yes. So you could figure out, A, what's getting you the largest percentage distance traveled between, or of like the trip between Brisbane and Cardiff, and also the largest percentage of water only. You may have to Yeah, famished edits. The linear inequalities, yes. So I have a particular way that I prefer to do them if you want to hear about that, but we can worry about that in a bit. Okay, help me out with that. What is geodesic distance? Okay, yeah. Yeah, that's not a problem to me. So, I mean, your great circle distance is going to be, you know, whatever your angle to the center of the planet is going to be. Right, so we call that theta. S equals r theta. That's why I curved it. Dot product of the vectors, and they are cosine.
It's only until all this is over.
Steve McQueen's blitz is a triumph.
Yeah.
Your son did not arrive at his destination. You were meant to be looking after him. Where's my boy?
Critics rave. Saoirse Ronan is superb.
I just want to go home.
A monumental achievement in British.
You can also do like what gets you the greatest, right? What gets you the greatest angle at 100%.
Subscription required.
That's not necessarily going to help because, like, that way might get you. Never mind. Jeff, have you heard Henry Rollins' Brisbane show? If you know who Henry Rollins is, of course. Okay. And again, you could use like some sort of fitness function to determine the best ones, which would be like, okay, what gets you the largest percentage of water only and the largest angular distance or the longest longest percentage of the trip covered using only water. Yeah. Between any two given cities on the planet, you should be able to figure out what is the shortest distance by water only. And yeah, again, humans can do this, no problem. The other thing you could do, if you wanted to restrict this, you could restrict it to just pick distances to coastal cities, so that you're not doing a literal, like, or at least like as a preliminary. Like, find the best find the best city-to-city segments that'll get you from wherever you are to wherever you are. That gets you the highest percentage of water only. And then you could clean it up from there. Yeah, you can't reach the landlocked cities, obviously. Right. Try to go city to city. What's the largest distance you can get? Sorry, what's the shortest distance you can get going city to city only? And then highest percentage of water only. And then you could say, okay, now we're going to do it starting from this. However many segments it takes. Then you go, okay, we're going to do what's going to get us the most great circles to just go from Brisbane to Cardiff. Oh, man. I mean, no, but the thing is, like, if you have 500, nah, if you have 100 coastal cities around the planet that you have selected to be on this map, it at least gets you kind of a reasonable approximation to start from, and then you might be able to say, okay, starting from here, then what can we do to get us, like, all of the is then you've also got sort of an intermediate value theorem where, like, you've got something that your initial guess is going to be too far, and then, like, any of the other guesses are also going to be too far, so you should be expecting something to be better than that. Yeah, I mean, you can use random points in the ocean, but that's not the point, right? Maybe. But the thing is, right, if you... So I think that the actual shortest distance that's going to get you from Brisbane to Nome, right, is going to be like, start at Brisbane, do a great circle until you get close to this island, whatever that is. Then, do a great circle until you get to Nome. Then, do a great circle until you get to Scotland. Then, Quingalis, good evening and welcome. If you have a pixel map, you could use A-star algorithm with the heuristic distance being great circle distance. That's been a while since I've heard that one. What is A-star algorithm? Graph traversal and path search. Yeah, there we go. O-space complexity. Yes, that is going to be a problem. But like I said, if we can kind of narrow it down and say, okay, we're not doing random. Best first search, yeah. Right, so that becomes an interesting problem in terms of trying to figure out where the best is going to be. But every single time, like, as long as you're picking great circles to go from point to point to point, it doesn't have to be the cities, but just to say, like, somewhere in this area, we're going to pick, you know, 1,000 different points. 1,000 is almost zero computer time at this point. Pick 1,000 different points and run the numbers in terms of, like, what's the largest great circle we can make going to any one of these 1,000 points, starting from wherever we are. Goodness. Groovy Jeff, huh? Yeah, so I don't know. I'm still thinking you want to find the greatest great circle, the largest great circle that you possibly can. That like completes the largest percentage of the journey using only water. And if there isn't one, then you need to find points on land that will break that into 2 segments. And then, like on each iteration, right? Find locations on land that will increase the distance traveled by the least amount and increase your percentage water by the most amount. What I'd want to do anyway. Oi. I mean, it's not going to help me necessarily, really. Can I code it to you if you give me the specs? No, not really. Like, I know how to program. I don't necessarily know how to actually, well, I could do some code. We've done a bunch of Project Euler stuff on this channel before. Where are we? That one. So here, I mean, we've only done the first 7, so like, but here we want the largest product in a series, so we're given this 1,000-digit number, and the 4 adjacent digits in this 1,000-digit number that have the greatest product are 9989, which appears here. 9989. Find the 13 adjacent digits in the 1,000-digit number that have the greatest product. So, like, this kind of stuff we've done before. It's just, it's kind of hard for me at the moment because, like, oftentimes we're coming at this kind of late at night. and I'm not a great programmer. Pixel map is approximately 1 gigapixel. Nice. Implement a star algorithm based on the input you have. Also possible. Just trying to hook me into a commitment before share. Lol. And that's the other thing, is that if you can solve it for smaller grids easier, then make this a smaller grid. You could actually do the globe as like a, 1,000 by 1,000 grid. Do it that way, and then scale it up. So keep increasing. As you increase the number of breakpoints, also increase your resolution. So by doing a 43,200 by 21,600, you'd probably only need like, I don't know, 10 iterations or something like that. Sometimes a white pixel turns black. Okay, fine. But ideally, right, it's not going to change it fundamentally. It's going to change it a little bit. Because you're not going to be like, okay, give me a globe that's got 20 pixels by 20 pixels. You're saying that the initial one should probably be 1,000 by 1,000 or something like that. And it's not going to change it incredibly much. At least I don't think so. Maybe I'm wrong. It's fine.
We know, music interruptions aren't fun. But real quick, heard of Labara Mobile? Maybe? A Which recommended mobile network with a 4.8 star rating on Trustpilot. Oh, and also named the most popular mobile network at the U-Switch Telecoms Awards 2024. Well, we just had to tell you that now you can join Labara from just £5 a month. Low cost, without the low quality. Join Labara from just £5 a month. Labara, the smarter mobile network.
The other thing that you could do is manually insert that particular one. No, I'm not that good of a coder. Like, especially not like in the moment. I ended up learning Visual Basic from one of my friends at this insurance job that I was doing, and within 30 hours had programmed something that would basically just replace me. I just ran it all day and then took care of its errors. And they were like, how did you do this? I was like, well, we just took a 2-hour process and whittled it down to 5 minutes. So I did some programming. I looked at my job process and I went, wow, this is stupid. I don't want to do this anymore. Yeah, I mean, like if you have certain things that you know are not going to show up, you hard code them in. You say like, okay, these pixels here are just going to be black or blue because they belong to the canal system, which is going to be tiny. right? A river that you use, the Great Lakes, right? Like, your computer might yell at you because it can't get to Erie, Pennsylvania from outside the St. Lawrence River. But you'd be like, okay, well, I know for a fact that I can get there. So the St. Lawrence River and all of the individual things that are there, like, need to be there. You know, rivers would be helpful to have, even just as like a, as long as the resolution is decent enough, right? Then hard coding some of this stuff in might be necessary. Yeah. But then you also have to make it only navigable rivers. So like, that whittles it down a bit. So you can say, I only want those that are above a certain size. And like, you know, as long as that, or size and depth. And as long as that's true, then we'll include those. Swimming pools, yeah. What a country, let me tell you. Oh yeah, that reminds me. We should do this. Who's gonna race me to it? Nope. Okay, we're gonna do a, which, anybody who hasn't seen this one before, we are slowly going through John Gould's Main Lingo, A Wicked Good Guide to Yankee Vernacular. And we are going to pick a place in the book to be able to select sort of at random-ish. And we go through and we say one of our vocabulary words that is going to represent our main vernacular. So, GAM, G-A-M. This word means a school of whales. It was given an additional meaning by Maine sea captains, who used to describe a gathering of home folks in foreign ports. In Singapore, Rio, Liverpool, the captains, and families if present, would visit together and have a talk fest. One evening during a regatta of the Friendship Sloop Society is devoted to a skipper's gam. Check that one off the list. Woo! All right. How we doing? Is Dr. Gold on right now? Because I think... Yeah. I think now's about a good time. We've got an ad coming up in 3 minutes, so I think if we just head on over to see Dr. Gold. Anybody who has any questions about other cool stuff, you can ask the question in Dr. Gold's channel, and he will be happy to help out. So he's doing some calculus at the moment. Looks like chain rule. No, sorry, product rule. Alrighty, so we're going to come back on Friday, certainly, for gamey type stuff. Probably doing Satisfactory, maybe a couple other random things. I might be doing something tomorrow. It kind of depends. We have family coming over on Thursday night. But that shouldn't affect stream because I stream after 9 o'clock. Generally speaking, they're going to be going to bed before then. So, provided the jet lag isn't too bad. They might go to bed after midnight. Who knows? Alrighty. I'll see you all later. Hope you have a good rest of your week. And my name is Obi-Wan Pez. This is N Simplex Pachinko. We'll see you next time.